Welcome, and thank you for coming today. Today, I want to talk about the troubleshooting method in container environment while maintaining the high security. My name is Kenji Kazumura, and I'm working for Fujitsu. And the reason why I want to talk about this topic is usually when using a container, the troubleshooting and security are usually considered as mutually exclusive. And there is another demand when using container, that is startup time faster. So it's usually difficult to satisfy all three requirements: security, troubleshooting, startup time faster. So at first, I will talk what is the problem and why we need to compromise one of these requirements. And after that, I will show some troubleshooting method to avoid these compromising. So my name is Kenji Kazumura, and I'm working for Fujitsu. Fujitsu provides some Java-related products, such as application server, which is one of the Jakarta EE compatible implementation. Fujitsu also provides microprofile implementation called Launcher. And I'm some members of Jakarta EE and microprofile working group. So let's start the first topic. When using container, we sometimes feel like a kind of dilemma about troubleshooting. That is, when we start the troubleshooting, we do not always have enough troubleshooting in the container environment. But it's not specific to Java, but Java user more likely feel to it because there are a lot of useful troubleshooting available for Java. But before going to the detail of the dilemma, so let's look at why we need to use the container. What is the motivation for using container? So there are many motivations for using container. Easy packaging, portability, lightweight, isolation. These are good reasons for using container. But the point here is troubleshooting and security are not typical motivation to use containers. So in this session, I focus on three key elements: startup time, and security, and troubleshooting, because these three elements are very important when using containers. Startup time is crucial because we use container, and container itself is lightweight, so startup time is important. And security is also vital because the current high demand for security, specifically the political demand. And troubleshooting is also necessary because trouble always happens in the real system. So troubleshooting is very important. So in this session, I look for the way to satisfy all three requirements. This three-dimensional graph shows the position of container. Three axes represent startup time, security, and troubleshooting. And the ideal position is here. All three requirements are satisfied. But right now, I plot the current position is here. So the startup time is good because we use a lightweight container. And troubleshooting is also good because we can use almost same tool as the ones available on premise environment. But security is not good. So in this session, the goal is move the container position from here to ideal position. And when using the container, there is another demand that is using smaller size image. The reason for this is there are two reasons for this. One is faster startup time. It reduces downtime and reduces the scaling out time. And the other reason is high security. Generally, the fewer OS library makes lower security risk. So here, now, the security motivation coming up now. But still, there is no motivation for troubleshooting when using container. And this is analysis of the startup time. About 60% of startup time spent in pulling image. So the smaller size image makes startup time faster. It's clear. And the main reason to use smaller size image is security. So many people create a kind of security practice like this. Here is one example, but the other one also the same contents. It recommends using smaller base image or minimize user privilege or do not include key or password in your image and so on. But question here is why is smaller size image good for security? So when building your image, we usually use the latest image of the OS-based image. So at that time, there is no vulnerability in your image. But as time passes, vulnerability increases. So when a vulnerability detected in a library within your image, you need to rebuild your image, even if you do not use that affected library. This is the reason why most of the security practices recommend to use smaller size image. So this is a screenshot of Docker Hub web page. Docker Hub provides some vulnerability information like this. And this is an example of JDK 23. And this image was pushed 4 days before I took this screenshot. But already there are 3 critical, 1 high, and 3 medium, and many low-level risk vulnerability. So this is a reality. So now we understand smaller size image is good for security. But next question is, how can we make the Java image smaller? So there may be a couple of ways. One option is using distroless image, which is a very small image. And another one is using JRE, which is a subset of JDK. And JRE does not include some tools, such as Java-C or Java command. And JLink is also the other option, which creates the runtime package, which include only necessary Java module for your application. And maybe there are more options, but here I don't want to go to the detail of how to create the smaller size image because it is out of scope for this session. But here I just want to briefly talk about the distroless image. Distroless image contains only Linux kernel and very small necessary minimum libraries to start Linux OS. So if your application needs more library, you must explicitly add them to your image. And distroless were originally developed by Google, so they are available at gcr.io. And Microsoft also provides a Java version of distroless image. So distroless is very good for security because they don't include unused library as security practice recommended. But the problem is you cannot run any command other than the command specified as entry point in the Docker file or port definition. So you cannot run any very primitive command like ls or ps. So I just let me show some example. So here is a distroless image of Java 21. And now I want to learn the Java version. And I specify Java at the entry point and specify the minus version as a parameter. And using this distroless image. So the result is expected. The output is Java-version. But if you want to learn the ls command with the distroless image, I specify the ls at the entry point. So it's complained that ls command cannot be found in distroless image. Okay. So this is a distroless. So when the trouble happens in the distroless image, you cannot investigate any trouble. Okay. This is a problem. And JRE is also a good way to create a small size of Java containers. But JRE does not include a useful troubleshooting tool, which is always found in JDK, such as JCMD, JStack, or JDB. So again, when the trouble happens in JRE image, you cannot investigate any Java-related trouble. Okay, that's the problem. So there is a dilemma of Java container. The smaller size image is one of the methodologies to achieve startup time faster and enhance security, but it's not ideal for troubleshooting. So the smaller size image and troubleshooting are mutually exclusive. So you need to compromise one of them. So now we use smaller size image, and by using this image, we can move the container position from here to here. So by using a smaller size image, startup time and security are significantly improved. But on the other hand, the troubleshooting are getting far away from ideal position because we cannot use any useful troubleshooting tool in the smaller size image. Okay, next. So I will show some troubleshooting method with smaller size image. So we have a couple of ways, so let's look at one by one. The first one is exec subcommand, but actually it is not useful with smaller size image, but it's start line. Exec subcommand means the Docker exec command or kube control exec command. By using these commands, you can access the internal system and the process in the container as if you are in the container. But as we discussed earlier, you do not have always the sufficient troubleshooting tool in your container. It depends on what tools are included in your containers. And when using these commands, you likely feel that you log in to the container system, such as using SSH, but actually it's just change the namespace. So what is a namespace? So understanding the namespace is very important because container system are heavily relied on namespace. So I here just briefly explain about namespace. Namespace is managed by inode. And the purpose of namespace is to separate some resources by using 8 different namespaces. That is C group, net, IPC, UTS, user, PID, time, MNT. So you can imagine the meaning of this namespace, but UTS means a Unix time system, that is a host name or node name. MNT means a mount point or a file system. And you can set share or not share for each namespace. So let me show some example of namespace. The typical command of namespace is lsns. It's a list namespace, and the left column shows the inode number. And I use the small Java program in this session. It's called sleep.java. It's just print date and print hello and sleep. And I also create a Docker image with this program with JRE image, but not JDK. So I have already the sleep image using this program. And now I run this image. So it works. Java print the date and hello. And in another terminal, I run the Docker exec. So here, I just enter the sleep container. And again, I run the lsns command. So compare with the previous result. So left hand is the outside of the container, the namespace of outside the container. The right hand is the namespace inside the container. So please look at the inode number of both of the namespace. Some are same, but some are different. For example, time is same number, but MNT is different between the outside the container and inside the container. So this is a namespace. And of course, we can see the process of Java in the, with the Docker exec command. But I use this container. I use the JRE image for this container. So we cannot use, for example, JStack command because I use JRE image. So this is a problem. We cannot use any troubleshooting tool with Docker exec command. So this is a exec command. And next method is access the container from node. If you have the privilege to access the node or host, you can see the process in the container from outside the container. But problem is process ID are different. So let me show some example. This is outside of container, and actually we can see the Java process, Java sleep, but look at the process ID. In the container, the process ID is, of course, 1, but outside the container, we can see the Java process, process ID of Java process is not 1. So this is a problem. So it makes it difficult to identify which process belongs to which container. And another problem of this method is it is difficult to sometimes some specific trouble, like such as a network problem. Because net namespace is also different between in the container and outside the container. So it is difficult to investigate a network problem because net namespaces are different. And the main problem of this method is you need access privilege to the node or host. It is not a typical case. And there is another way to create a container which has same namespace on node or host. But again, it is not useful because the namespace of node and in the container are different. So next method is sidecar method. I think most of you know the sidecar. And a pod is a set of containers, but as default, PID namespace are not shared among the container in a pod. So a process in one container cannot be seen by the process in other containers. But there is a way to share the namespace among the container. How to do that? First, you prepare the application container with a smaller size image, such as JRE, and also prepare the debugger container, which includes a lot of useful troubleshooting, such as JDK. And at this moment, there is nothing different from the usual pod. But the difference is this flag, spec.share process name to true in the pod definition. So by setting this flag, you can create a pod in which the container can share the PID namespace. So you can use any troubleshooting tool in the debugger container to application container. So it looks good, but the problem is you must always invoke the sidecar when deploying a pod. So it's wastes the computational resources. And security is also bad because the debugger container is usually a large size image. So next method is copy method. The left hand shows the existing pod running the application container with JRE. And when issue happen in this container, you can create a new pod by using this command, kubectl debug and -copy -2 command. By using this command, you can create a new pod and copy the existing container to this new pod and create a debugger container and add it to the pod. And debugger container can share the PID namespace. So let me show the example. So first I run the sleep pod. I use the sleep image that I used before. And make sure the pod is running. Yes, running. And make sure that Java is running. So it's output the date and say hello. And I run the copy to command, kubectl debug, and copy to specify the new name of the pod. I specify right now debugger. And container option is specify the new debugger container. I specify Temurin at this moment. And I specify the JDK image as a debugger container. And do it. And let's see the pod information. So you can see the two pod here. The sleep pod is an existing pod, but here we can find a new debugger port. And look at the number of container in debugger container. It shows two. So there are two containers in debugger port. So let's see what happened in debugger container. I use the kubectl describe command. And you can find the container section. You can find sleep container. It is expected container. And also you can find another container that is called Temurin, which I named here as a debugger container. And Temurin container use JDK image. Okay, so there are two containers in a new port. Of course, you can see the process of Java, but look at the process ID. Process ID is different from one, not one. But you can use a troubleshooting tool for this process. Yeah, it works. So the one important thing to know this method is you do not touch existing port. So there are two ports and two container, application container. But these two containers are totally different. There are no relationship with two container. Okay. So this method is more resource efficiency than the sidecar method, but you cannot debug exact container in which issue happens. So it can be used the case when the issue is a very reproducible case. The final one is ephemeral container. Again, the left side shows the existing port running the application with GRE image. And in this time, when the trouble happens in this container, in this time you don't need to create a new port. Instead, you can just add the new debugger container as an ephemeral container. Ephemeral container can share the PID namespace with application container. So let me show the example. So make sure the port is running. The application container is right now running. And in this time, I use target option for debug command. To specify that -- target, you can create a new ephemeral container. And again, the container is the name of new debugger container name. I specify Temurin here. And I use also the JDK image for the debugger container. And do it. And let's see the port information. So in this time, only one port, no additional port. And please look at the number of containers in the sleep port. It's just one, okay? So let's see what happens in this sleep port. Again, you can find container section and you can find sleep container. That is the expected container. But there is no other container in container section. But you can find a new section called ephemeral containers. This is a new container section, and you can find the Temurin container here. And it uses JDK image. So actually, there are two containers in sleep port, but Kubernetes handle the ephemeral container differently from the usual container. So this shows only one container. It seems to be one container, but actually there are two containers in sleep port. Okay. Of course, you can see the Java process in the ephemeral container. And important thing is the process ID is the same as the original port. Process ID is 1. And of course, you can use any troubleshooting tools in ephemeral container, like JStack. It works. Okay. So this is ephemeral container. Okay, I show some troubleshooting method with smaller size image, starting with exec sub command. But it is easy to use, but actually it cannot be used with smaller size image. And the last one is ephemeral container. It looks good, and it seems to be the perfect solution, but it also has drawbacks. Once you create ephemeral container, you cannot delete or detach it, even if after you are debugging. Anyway, so I show you some troubleshooting method. So you can select one or two of method according to your container environment. So this is the final version of Grass. Finally, we reach the ideal position by using ephemeral container. So 3 requirements, startup time, security, troubleshooting, are satisfied, finally. So wrap up. So at first, I introduced a kind of dilemma of Java container. It is difficult to satisfy 3 requirements: security, startup time, and troubleshooting. And we usually compromise one or two of these requirements. And after that, I show some method for troubleshooting. And these methods can mitigate or navigate this dilemma. So if you are interested in this kind of dilemma, please give this method a try. So this is all of my presentation. Thank you very much. So I have some time, 1 minute or so, if you have questions. Yes?
Yeah. Do you know why you can't remove an ephemeral container?
Move from?
Why can't you remove the ephemeral container?
Well, I'm not sure. maybe OS people should ask to OS people. Yeah. Okay. Yes.
The idea was to use a small container or have a light image without a GUI, only GUI, right? And then we can debug our application because there's a lot of comments.
Yeah.
Then we need another container that contains GTK to use these comments. Why I just run my app in the second container, and then I have access to all these comments.
Yeah, that is I show you the maybe a sidecar method. You can do that, but you must invoke the sidecar at the startup time. Okay, so it may be the resource is not efficiently used, but if you accept that kind of usage of the resource, you can do that. It depends on your environment. Okay, thank you very much.